So just to give you a little feel for how things are changing in the Indian grid scenario, right? All the way from renewables with a lot of wind and solar coming into the grid, that is going to create a challenge with respect to the intermittency issues associated with wind and solar. And these are all happening at a very, very rapid pace. And so what that means is it's going to create tremendous opportunities for for technologists to really figure out how to manage this intermittency, either using energy storage or through controls, or even balancing the energy load situation, right, at any point of time. So that's one piece on the generation side of it. Then on the transmission side of it, there is a lot of focus in terms of how do you improve the reliability of the transmission grid and how do you prevent blackouts. There, a lot of digital technology with respect to sensors and information from across the grid, devices such as phasor measurement units, they are playing a big role, where today you can actually capture the voltage and current data on different substations across at a very, very rapid space, almost like 120 samples per second. The next question is, how do you use this information to make judgment on how far the grid is away from collapse and how you can better efficiently manage your transmission grid. And when it comes to distribution related areas, it's primarily on figuring out how do you improve the reliability, efficiency, and quality of the distribution grid, subject to the fact that you're going to have a lot of PV, that is solar, into the distribution system, as well as electric vehicles. So a couple of technology challenges there is on the solar integration to the distribution grid. Whenever a cloud passes over a solar farm, right, there is going to be a big spike in the voltage that you might have in the distribution system. So you need to have appropriate controls to be able to manage that. And the way to solve some of those is primarily to get all the data from the different components of the system and really figuring out how do you make the system better. And then with respect to electric vehicles, that's quite evolving. And when that happens and when people start charging their cars and their homes, the impact of that on the distribution transformers and all is going to be an important area of work. So that is an area where, again, you've got to collect a lot of data, to really figure out how to manage this entire grid together. So one, it's an end. People have to look at this whole digital transformation as an end-to-end system, complete system. You need to think through cross-domain, so it's not only digital or it's only the physics of it. It's got to be a combination of physics and digital all put together in making an impact to the entire grid. So I do see a tremendous amount of opportunity leveraging the digital space or technologies to help improve the system and make us better prepared for our future. The last topic I would just connect is on the distributed power. With so much opportunities in India on microgrids, right? With the fact that the solar systems costs are coming down and the fact that even energy storage costs are coming down, it's almost like a no-brainer that we would potentially see a combination of solar storage and potentially some diesel as a backup, kind of systems across the entire country. And how do you monitor that? How do you really look at how you can manage this entire systems from a remote place? Their digital systems play a huge role, and that can really take us to the next level at a much faster pace than what we are thinking.